In this video, I will go over some of the trigonometric identities. So to start things off, I drew this rectangle, and I put some lines in there to create some triangles. Now I'll go ahead and label some angles. We'll call this angle A. I'll call this angle B. And because the top and the bottom of the rectangle, by definition of rectangle, are parallel, we have a transversal right here, so I know alternate interior angles are congruent. So together, this would be angle A plus B. So up here is be A plus B. What else do we know? Well, in this bottom triangle here with angle A, we know it's angle A, 90, and this third angle would be 90 minus A. We have 90 minus A. We have 90 right here. So 90 minus A plus 90 is 180 minus A. So therefore this angle here must also be angle A. So this big triangle down here and this triangle up here are similar triangles. Furthermore, let's go ahead and say that this line here is 1 unit long. So we'll say this is 1 unit long right here. Now we can start using our knowledge of trigonometry to start labeling the lengths of these four parts that create the triangle. So the bottom part of the triangle is just one line segment. This side, though, is two line segments. The top is two line segments, and the left side is one line segment. So let's go ahead and go through and start labeling these so we can see the trigonometric identities. So we'll start in this middle triangle, actually. So if this is angle B, we're going to assume that B is in degrees. If the hypotenuse is 1, then by definition, the adjacent side must be cosine of B. And then I'll go ahead and say this will work. Well, yes, it will work. I'll turn this around. And then this side over here, this triangle will be sine B. Let's go ahead and turn this rectangle back around. So if this side is cosine B and it's the hypotenuse of this triangle, then this leg of this right triangle down here must be cosine A cosine B. And, oops, didn't mean to move it, rotate it around. And this leg of the right triangle then would be sine A cosine B. Again, just a quick reminder of our trigonometric ratios. So sine of an angle is equal to the opposite leg divided by the hypotenuse. And cosine of an angle is equal to the adjacent leg over the hypotenuse. We're not going to deal with this in this video, but the tangent of a angle is equal to the opposite leg divided by the adjacent leg, or we could write that as sine theta over cosine theta. So if the hypotenuse is 1, then the cosine of B is going to be the adjacent leg divided by 1. So since cosine of B, the adjacent leg must be cosine B. And then the sine of B be the opposite leg divided by 1. So the opposite leg must be sine B. For A, the cosine of A would be this leg divided by the hypotenuse. Well, since the hypotenuse is cosine B, when we divide this leg by cosine B, we need it to equal cosine A. So cosine A cosine B divided by cosine B would just be cosine A. In a similar fashion, this leg over here must be sine A cosine B, because when we divide sine A cosine B by the hypotenuse cosine B, we just get sine A. So now we've filled in the legs for this triangle as well as its hypotenuse. We have the legs of this triangle as well as the hypotenuse. Now we can move around. Let's spin this a little bit. And we can start looking at this similar triangle here. We know that's angle A. So if that's angle A, the cosine of A would be this leg divided by the hypotenuse. That's going to be cosine A sine B. We divide cosine A sine B by sine B, we just get cosine A, which is this leg. We can then find the other leg of this triangle to continue to rotate it around. And we know that the sine of A is this leg divided by sine B. That's going to be sine A, I don't quite have enough room to fit it all next to that one, sine B. So this leg here is sine A sine B. So we just have one triangle left. We already know its hypotenuse is 1, so this will be pretty quick. The cosine of AB, or cosine of angle A plus B, is going to be this leg divided by 1. So that would be cosine A plus B. And in a similar fashion, the other leg, to continue rotating it around, sine of angle A plus B would be this leg divided by 1. So this leg must be sine A plus B. And now we have a nice little rectangle that'll help us with a number of the trigonometric identities. I won't go through them all in this video, but I will discuss a few of them. So for example, we know that, well, first of all, if you want to do some of the double angle identities, we can just say that A is equal to B is equal to, say, theta. So for all of these, we could rewrite, if A equals B equals theta, I'm going to do this in a different color. So I'll do it in, we'll do purple. We'll say if A is equal to B is equal to theta, we'd have cosine theta times cosine theta, which become cosine squared theta. That'd just be cosine theta. We'll spin it around here again. And over here we would have sine theta cosine theta. Here would just be sine theta. Here we would have cosine theta sine theta. And continue around. Over here we have, that'd be sine squared theta. Here we'd have cosine 2 theta. And finally, on the last side of our rectangle, we have sine 2 theta. So we'll go ahead and do some double identities, but you can, if you take a list of trigonometric identities out, hopefully you can find them on this diagram. If you can't, you want me to help you, you can leave a comment or email me and I'll help you out with it. Let's go and take a look at some double angle identities. So what do we know about cosine 2 theta? What do we know about this distance from here to here? Well, we know cosine 2 theta plus sine squared theta, that's this entire length up here, that must be equal to this length down here. We know that's equal to cosine squared theta. If you subtract sine squared theta from both sides, you get cosine 2 theta is equal to cosine squared theta minus sine squared theta. Another kind of cool one I like, you can see right here, using this triangle right here, we can see that sine squared theta plus cosine squared theta equals 1 using the Pythagorean theorem identity. So they're all kind of locked inside this rectangle. If you ever have difficulty memorizing some of the trigonometric identities, perhaps drawing this rectangle out with the triangles inside will help you. So I hope that helped. I hope you enjoyed the diagram. If you have any questions, please let me know. I'm always happy to help.